Hello everyone, in this video we're going to learn how to test for symmetry of polar functions. We have three types of symmetry. The first one, the polar axis or x-axis. If 2 points symmetric about the polar axis, their coordinates should be r theta and r negative theta, right? Because this one is counterclockwise direction and this one is clockwise direction, right? Now, we have another way. It's going to be negative r and pi minus theta. This guy actually, the points right here. The points right here, which is r pi minus theta, right? Because this one is theta, so this one is equals pi minus theta, right? Now, radius right here and right here should be the same, right? Now, to get this one, we need to take the opposite way of this one. So opposite way of this one, we just change the sign of the radius. That's why we have this one, right? Now, we just replace the coordinate of original points, which is r theta, with r minus theta, r negative r pi minus theta. If the resulting equations are equivalent, then we have the symmetry, right? Now, the second one, the line angle theta equals pi over 2, which is the y-axis, right? This guy and this guy symmetric about the y-axis. The coordinate of original point is going to be r theta. The symmetric point should be negative r negative theta. The reason why we have this one, we need to plot negative angle theta. It's going to be this one right here, right? This is negative theta clockwise direction, right? And the coordinate point should be r negative theta, right? Now, we need to take the opposite way of this one, right? In order for this guy symmetric about the y-axis, right? So we need to change the sign of radius. That's why we have this one, right? Now, we have the same points. It's going to be positive radius, but the angle right here is pi minus theta, right? Because theta is going to be right here. So pi minus theta equal this guy right here, right? Now we need to replace the coordinate of original point r theta with negative r negative theta, r pi minus theta, right? If the resulting equation are equivalent, and we have the symmetry, right? The last one, the pole or the origin, right? So the original point is going to be r theta. The symmetric point of the original point over the origin should be negative r theta, right? Because we just take the opposite way and we just change the radius. That's why we have negative r right here, right? Or we just literally add pi, right? We have this one is theta and then this one is pi. So we just add pi, we get this one, right? Now, let's take a look at the first example. Now we need to test for the function r equals negative 4 sine theta, right? Now the first one, we need to test for the polar axis, right? So we need to replace r theta with r minus theta, right? So I have r equals negative 4 sine of negative theta, right? I just replace r and negative theta, right? So then it turns out to be r equals negative 4 times negative sine of theta, right? Because the sine function is odd, so then sine of negative s equals negative sine of s, so keep that in mind, right? So this one turns out to be r equals 4 sine theta, right? And this one is different from the original one, right? So the function right here does not have the polar axis as a symmetry, right? Now we're gonna check for the second one, which is the line theta equals pi over 2, right? So we're gonna replace r theta with negative r and negative theta, right? So I have r right here, I just rewrite as negative r equals negative 4 sine of negative theta, right? So I'm going to simplify this one. It's going to be negative r equals negative 4 times negative sine of theta, right? Because the sine function is odd, right? So it turns out to be negative r equals negative 4 times this one should be 4 sine theta, right? I'm going to multiply both sides by negative 1. So I'm going to end up with r equals negative 4 sine theta, right? This is actually the original one right here, right? So the function has the line theta equal pi over 2 as a symmetry, right? Now we're going to check the last one, the pole of the origin, right? So we replace r theta with negative r and theta to see what happens, right? So r right here, I rewrite this one as negative r equals negative 4, right? Angle theta does not change, right? So I have sine theta only, right? Multiply both sides by negative 1, so r equals 4 sine theta, which is different from this one, right? So the function does not have the pole at the symmetry, right? Now I'm going to leave this one for you to practice. R equals negative 4 cosine theta. Note that cosine of negative s equals cosine of s because the cosine s is the even function, alright? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals, they take us higher. The night's young and it's just begun as she puts her hand in mine.